and welcome to another episode of the Margin Max Minute. I'm Paul Ayers, and as always, thank you for joining me today. We are on number 7 of 10 in our cost reduction series. Today's subject is maintenance optimization. And it's so important to maintain our assets, maintain our processes, maintain the skill sets of our people. But today we want to hone in on a little bit more precise definition of maintenance optimization, where I want to define this as the process of improving the efficiency, the reliability, the cost effectiveness of our maintenance activities. And this is going to apply to you whether you have a service business or a manufacturing business. In a manufacturing business, we have machinery, we have equipment, we have production facilities, and we may even have items that move our inventory in our warehouses. In the service industry, we minimally have the upkeep of the infrastructure that supports our service industry. We might have offices. We might have IT systems, most certainly we do. We may have vehicles. We could have buildings. We could have things like ovens and various other attributes that need to be maintained so that we can count on them, so we can have timely delivery of our service offering. So I'm going to cover 3 basic areas in this maintenance optimization cost reduction series, and they really are very much the same of whether we're a manufacturing operation or we are a service operation. So the first one I want to talk about is essentially minimizing downtime through a good maintenance program, through optimizing our maintenance program. And in a service business, let's say we use a delivery vehicle and it's time to do an oil change. We want to make sure that we schedule that oil change in a way that it doesn't disrupt what we're trying to do. We want to be able to predict when that is by either miles or hours on that car or truck and get that in on time so we don't have any downline issues. Of course, we run into that in manufacturing too, but a big difference in manufacturing when we're talking about minimizing downtime is actually reducing equipment failure. Equipment failure occurs, for instance, if we have a bearing that's making a noise. Let's say it's squeaking. Like every other rotation, we can hear a little squeak and we ignore that. All of a sudden that bearing goes out. Because the bearing went out, it broke the shaft. Because the shaft broke, we ruined our electric motor. Because the electric motor broke, whatever powered system of conveyance or manufacture that we have failed. We might have just an unbelievable cascading of equipment that went from a basic maintenance item to a catastrophic failure of a whole system or at least a component. In the service business, if that same service person continually delayed and did not do their oil change, they might end up in a situation where a piston in the engine block actually seizes up and the car stops right there. That's kind of hard to imagine in this day and age, but it would be the equivalent to a major equipment failure in a manufacturing business. The second one I want to talk about today in a way to reduce costs through maintenance optimization is the efficient allocation of resources, and that is being deliberate in when we're going to spend the time and money in order to avoid unnecessary expenditures or get in a really reactive mode in the same. When we're reacting to maintenance, we might have to call a more expensive service provider for that repair, charging an expediter type added fee on top of what we normally would have to pay, and we're spending more money. The other item in a manufacturing space on the same idea in increasing operational efficiency is simply minimizing the amount of times we start and stop machines, production lines, whatever we're trying to do. I mean, this is going to be the same in a kitchen for a very busy restaurant where they're very process focused. It's a great place for an industrial engineer, and most really good operations, cooks, top chefs, are absolutely super talented at being efficient. If their oven would break down in the middle of something, it would be as catastrophic as an end loader in a crushing operation in a gravel pit. But what I'm trying to get at here is we want to minimize the number of starts and stops. Every time we start and stop something, we lose efficiencies. We're not allocating our resources effectively. What we know is that steady state operations of production assets are the most efficient. So we want to really work on being predictive and deliberate when we're going to shut things down in order to execute our maintenance requirements. And the last one I want to talk about, and this again applies to both service businesses and manufacturing businesses, and that is a good maintenance optimized program is going to extend the life of our assets. Back to that car example or truck example in the service business, if we really do make sure that we maintain that vehicle with good oil changes, tire rotations, checking fluids, all the things that we normally do, we're going to maybe go from 80,000 miles to 160,000 miles. If we take good care of that vehicle, we're going to extend that asset's lifespan, and we're going to lower the total per period expense to run that particular asset across what we're doing and lower the total cost of ownership. Now, in manufacturing businesses, companies are constantly trying to get more out of their assets in terms of useful life by having maintenance programs that they really stick to and they really execute upon so that they get the maximum life out of there. What I want to close with is please challenge yourself on of just where you are on your comfort level of the optimization of your maintenance system. I know I've been enjoying into the fourth generation in the 11th decade of a very successful non-metallic mining and aggregate processing business. And I know we have a substantial way to go, especially with the new technologies coming out in terms of predictive maintenance. The advent of what we're referring to as machine learning and artificial intelligence actually utilizes sensors to collect data in order to predict when certain things are going to happen. That bearing I talked about earlier, when that shaft starts to deflect just in microscopic amounts, we can start to predict that the bearing's starting to fail and schedule that maintenance sooner and later so we don't have that domino effect of a catastrophic repair into our whole production line. So I hope this has been helpful. Please contact me at my website if you think I can help you out. I would love to do it. Maintenance optimization is an exciting and high potential area for you to reestablish your interest in, especially with the advent of machine learning, unbelievable computing power and data storage that we again are referring to as machine learning or artificial intelligence. It's time to dust that one off and see if you can really make a difference. If you want some help, give me a call. Check me out on my website. Otherwise, I wish you the very best week, and it's time to get to work.